Hello, everyone. I am Angie Jones, Head of Developer Relations at TBD, which, yes, is Block's newest business unit focused on open source technologies. Has anyone ever ordered alcohol from a delivery app? If you have, I want you to reflect on what that experience was like. Now, no matter if you're buying in person or online, there's two things that you need in order to purchase alcohol. You need money and you need identification. And when buying in person, you can easily provide both of these things. However, when buying online, we run into a bit of a snag. See, we've figured out how to accept payments online. However, we don't have a good way to accept physical forms of identification in a digital way. So the normal checks are skipped and the order is placed and paid for. The poor delivery driver is now liable for checking your ID and verifying your age when they deliver your purchase. And if they happen to forget to do this, they could face serious consequences as this is mandated by law, right? So the delivery person could face fines, they'll surely lose their job, and the delivery company itself could lose its license to sell alcohol on its platform. But they aren't the only ones on the hook. We have the vendor as well who sold the alcohol to this person. So they are required to verify the customer's age. They too are relying on the driver to do the check and to send them a confirmation. And if this doesn't happen, then their business is at risk as well. So let's say that the delivery driver does remember to verify the age, but the buyer is a minor or doesn't have a valid ID. Well, now we've just wasted a lot of time and money, right? The delivery driver must leave and return the alcohol back to the store. The delivery company must process a refund, which they need to get back from the vendor. So, as you can see, this is quite the risky transaction. Fortunately, there's a way to handle this digitally. So I live in Louisiana, and we're one of the first states in the US to have a mobile driver's license. And my mobile license serves as my digital ID, and it's held in a secure digital wallet on my phone. Now, the wallet is connected to our government system, so it's able to pull my latest data in real time. And because they have access to my real time official government data, they're able to prove that I am of legal drinking age. So here's how the scenario changes. A customer uses a delivery app to order alcohol. The delivery app requests the proof of age. The customer shares a credential provided by their mobile driver's license app, and that credential is verified by both the delivery company and the vendor. They see that it was issued by the Louisiana mobile driver's license. They trust this entity because they know that it has direct access to government data. Now, with proof, they can confidently deliver the alcohol and not burden the poor driver with such an important task. Also, if the digital proof was not valid, then the order simply wouldn't be processed, right? So you're not wasting time delivering the order and dealing with refunds. So, how is this done exactly? Well, it's using JWTs, which are JSON Web Tokens. And a JWT is a secure string representation of claims that can be easily shared between two parties. So, we typically see JWTs used by websites to authenticate users, where the server would generate a token that certifies the user's identity and then send that token over to the client. The client could then use that token to prove the user's identity in future requests. So this helps the server verify that the requests are coming from an authenticated user without needing to recheck the user's credentials each time. So Given these characteristics, it makes the perfect choice to implement the open W3C standard called verifiable credentials. These are a special type of JWT that can be used for more than just authenticating to a website. They can be used for pretty much anything, such as proving your age, which is how I was able to buy booze with a JSON Web Token. Now, just like JWTs, verifiable credentials are cryptographically signed JSON comprised of three parts. So we have the header that's indicating what type of JWT it is, as well as the cryptographic algorithms used to sign and verify the JWT's authenticity. We have a payload, which is the actual claims expressed in JSON. This is the magic, the key here, because pretty much anything can be expressed in JSON. And then the final part is the cryptographic signature of the person or the organization that issued this JWT. All right, let's double click into the payload so that you can see what the verifiable credential looks like. So it contains the type of credential. This will always have the type of verifiable credential, but you can add any more. Notice that this is an array. You can add other types here. And then it also contains the issuer's ID. So this is a decentralized identifier. And then it contains when it was issued. If there happened to be an expiration date, that would be contained there as well. And then the claims about who it was issued to. All right. So there are three actors involved in verifiable credential flows. We have an issuer, which is the entity that creates and issues a credential. We have the holder, which is the person the credential was issued to. And then we have a verifier, which is the entity that accepts the credential and verifies its legitimacy. All right. Okay, pop quiz time. So in the scenario that I described with the alcohol delivery, which actor does the customer play? The issuer, the holder, or the verifier? The customer plays the holder, right? So they are the one that holds the credential. They're the one that the credential was issued to. Okay, good. Next question. Which actor does the delivery app play? The issuer, the holder, or the verifier? So the delivery app would be a verifier. They're the ones that's requesting that the holder present a credential so that they can verify their age. Okay. How about the mobile driver's license app? Is that an issuer, a holder, or a verifier? The license app would be an issuer. So they're the ones that have the data and the proof, and they can issue a credential attesting to that proof. Okay, last question. Which actor does the vendor play? The vendor is going to also be a verifier. So both the delivery app and the vendor would both need that proof sent to them that the holder is over 21. All right, great job. So the Louisiana Wallet app has access to my data, but verifiable credentials are a privacy preserving technology. So if I had to show the delivery person my physical ID, they get a lot of information on me, right? But the mobile app isn't sharing any of that. In fact, they aren't even sharing my date of birth. They can simply issue a credential saying that I am over 21 years old. All right. So here's how you create a credential. I'm using the Web5 open source SDK to create a verifiable credential that would resemble one that was issued by my LA wallet. The type is set to age over 21 credential. Now, remember, I did tell you that one of the types needs to be verifiable credential. That's done by default by the SDK. So you can just add the additional ones that you want here. And again, this can be set to anything, but we do need some standardization here so that verifiers know what to look for. And we'll talk about that a little later. The credential also holds the decentralized IDs for both the entity that's issuing the credential. Again, that would be my mobile driver's license app. And then also shows the ID of the subject. So that would be who the credential is about, the holder. So me in this case. And then the data section contains any claims the issuer is making about the subject. So in this case, there's only one claim here, and it's a test that the subject is over 21. Okay. Then the issuer would cryptographically sign the credential with their decentralized identifier, which contains a private key. So this signature is how the verifiers can be certain that the credential actually came from the issuer and that the credential has not been tampered with in any way. Okay. Now, once it's signed, a JWT is returned, and that's what lives with the customer. That's what's shared out to any parties that need to verify this. And that JWT can be stored in their wallet or on their device. And in my case, it's stored in my LA Wallet app. Now, when an entity requests that someone presents a verifiable credential, that verifier has to provide a definition. Technically, it's called presentation definition, which is why I named this variable PD. Okay. And that definition will indicate the type of claims that will satisfy whatever it is that they need to verify. So in this case, the delivery app and the vendor company request a credential that has a claim named over 21 that has a value of true. Okay. So LA Wallet would then programmatically select the credential from my wallet that will satisfy this definition. Now, again, unlike a physical ID where I need to share a lot more information about myself, that's not required with the use of verifiable credentials. This select credentials function allows the wallet to only provide the information that's being requested, nothing more, nothing less, right? And then my LA Wallet provides the delivery app with this credential that has the Boolean value saying, yes, she is of legal drinking age. Because my mobile driver's license app is a credible source, them vouching that I am legal is enough proof, right? The delivery app doesn't need to know my exact date of birth. And this is known as zero knowledge proof, right? Basically, you trust the source who is saying something so they can provide their word without giving you the actual data. All right. There's also a technique called selective disclosure, where let's say I have a verifiable credential that contains like maybe 5 different claims about me. But when I'm reusing this credential in a different scenario, that verifier may only need like 2 of those claims. Well, the wallet can selectively disclose the 2 needed claims and hide the other 3. Okay. Now, when the delivery and the vendor companies receive my verifiable credential, again, in the form of a JWT, they will verify it. This function will verify the integrity and the authenticity of the credential, ensuring that it hasn't been tampered with, it's not expired. The IDs of the issuer and the holder are actually real and resolvable, things like that. Once they know that the VC is a valid one, then they can ensure that the claims contained within the VC actually satisfy the requirements that they defined. Okay. Now, verifiable credentials can be used for just about anything. So, colleges, universities, and other training programs have begun issuing verifiable credentials as a digital form of a degree. For example, MIT provides both the physical and digital forms of a diploma to its graduates. Think about how useful this is when this person has to undergo a background check, for example, as opposed to calling the university to verify that a candidate did in fact graduate with the degree that they're claiming. Anyone who needs to verify this information can simply request that the graduate provides a verifiable credential that's been issued by MIT. This can all be done programmatically, which greatly speeds up the process of the background check. You can also imagine these credentials being issued upon successful completion of a certification. For example, I'm certified in Java, right? So it would be cool to show this certification on my LinkedIn page, maybe even allow hiring managers to search for people who have this credential. Speaking of hiring managers, we're starting to see VCs issue to prove employment history as well. So these can be issued by employers themselves or even by other credible sources such as companies like Workday or an employment verification agency, for example. So that's the thing. Anyone can issue a credential. I just showed you the Web5 open source SDK where you could issue a credential yourself today, right now, right? But are you a credible source to make whatever claim that you're making, right? So verifiers must determine like which issuers they are willing to accept credentials from based on whether they trust that entity or not. And in this case, if your company uses a certain agency for background checks, if that same agency has already issued a candidate verifiable credentials for employment history that's been verified in the past, then that's wonderful, right? We can reuse those. And this has just saved time for your company, for the agency, and the prospective employee. So everyone wins here. In fact, imagine a scenario where you can apply for a job with proof of employment history and academic achievements in the form of verifiable credentials. I don't think we're very far off from something like this, which would help hiring managers kind of uh, go through applicants to see like which ones are actually qualified for the job. We're even starting to see countries like Aruba use verifiable credentials to allow travelers to enter the country without a physical passport. Um, so the credential selectively discloses the required information from their embarkation card, and the immigration authorities are able to verify the information much quicker than the old process that they were using, making it more secure for governments and more efficient for travelers. VCs have made their way to the medical sector as well. In addition to my driver's license, my LA wallet also holds things like my COVID vaccination cards. So that came in really handy when the world reopened after the 2020 pandemic and venues were requiring proof of vaccination, right? One of my colleagues, Rizelle Scarlett, also interviewed a pharmacist who talked about how they trade medicinal drugs as part of their supply chain management to ensure like pharmacists across the world are properly stocked, right? And pharmacists use VCs to ensure that the medicine that they trade and the pharmacists that they're trading with are indeed legitimate. At TBD, we're using verifiable credentials for financial services. Many companies are required by law to verify the identity of new customers in an effort to like prevent illegal activities such as money laundering or fraud, right? And this whole process is known as KYC or Know Your Customer. So we've created a known customer credential, which would allow users to present this to companies in order to meet their compliance and their regulatory obligations. So I hope by now you're wondering, all right, Angie, how do I keep my credentials safe? Like I got medicinal stuff, I got my educational stuff, I got my financial stuff. How do I keep these safe? So let's say that a bad actor got a hold of one of my credentials, right? Which again is simply a string of text. They cannot present this credential as their own because every credential, remember I showed you the subject field, every credential is issued to a specific decentralized identifier. And remember, the issuer signed the credential with their decentralized identifier. That's because decentralized identifiers have a public and private key pair. So to use a credential, you need to prove that you're the owner of the decentralized identifier that the credential was assigned to. And you cannot do that without the private key, which is typically locked away in like a key management service, right? And then even with this, wallets that are holding verifiable credentials need to equip multi-layered or some sort of sophisticated authorization methods, right? For example, I use biometrics to log into my LA wallet, which holds my credentials, just like I use biometrics to use the credit cards that are stored in my Google wallet, for example. Okay, so as far as challenges with this technology, I think the biggest one we face right now is the standardization and the interoperability of verifiable credentials. Now, remember, like these credentials are meant to be transmitted between parties, right? So they need to be verified programmatically, which means we all need to agree on the types and the terms and the language of the claims that we're going to use. For example, let's say my university issues me a credential. What should the type be, right? Should it be education credential? What if another university issues one and their type is degree credential? Maybe a third college issues one, but there's this university credential. So now you can see I've already broken like whatever verification program was written for the employment application example I showed you, right? Because they might be looking for a specific type. Now, the only way that a credential can meet the specified requirements is by matching the exact wording or at least pattern matching. So regular expressions are allowed, but the terms that the verifier is looking for needs to be present in that credential, right? So this goes for the type of the credential as well as the claims that are being made within the credential. So there are efforts to standardize the use of verifiable credentials on a global scale. Again, VCs are W3C a W3C standard. So there's a standards body that's comprised of individuals that are working for multiple companies, right? And they're all working on this together. So we just need companies to adopt and adhere to these standards. All right. So I'm really excited to see more and more use cases for verifiable credentials where it'll be easier to transact and to verify ourselves online. I look forward to the days when we can look back and laugh at times where we had to take a photo of our physical IDs and upload it to a website or scan our passports in order to apply for a visa to enter a country or do a liveness check on Zoom, right? All of this feels really archaic in light of this technology. If you want to learn more about verifiable credentials or issue some yourself, play around with it, you can do that with our open source Web5 SDK. Check it out at developer.tbd.website. Cheers to VCs. What questions can I answer?
That was wonderful. That was wonderful. Thank you. All right. We do have a few questions. I think you answered a bit of this, but I'm guessing they wanted some more detail of, can you discuss some potential security vulnerabilities associated with JWTs and how to mitigate them?
Yeah. So this question, good. When that slide came up, I was like, I hope you all are thinking about this. So this proves that they were thinking about this. Hopefully I answered it with that slide, but I'll reiterate now. So basically the credentials are issued to a decentralized identifier, which has a public and private key pair. Your private key is something that's kind of locked away and stored somewhere really safe, like AWS, Google, like all the major companies have like a key management system. I believe Apple even has one on device, things like that, right? And so you can store this there, and it's pretty good and pretty secure. But let's say that you didn't do that, and for whatever reason you got yourself into a pickle where your private key was exposed or something like that. Then you are at risk. If people have your private key, then they can basically pretend to be you, or they can even sign credentials on your behalf. But you can rotate these keys and kind of change them. So if your decentralized identifier was exposed in that way, you could do something to like kind of remove that key that's been exposed and get a new one.
Very
Also,
cool.
additional there was basically the credentials being behind some like two-factor authorization or biometric checks.
Very cool. Thank you. I was talking to Jay Miller that you were going to be coming on stage, and I'm like, I finally get to ask your Q&As and stuff, and it's really cool. And I say that because this is the first time I've ever heard about JWTs, so I like that somebody asked this question of like, what's resources do you suggest to learn more about it?
Yeah. So if you want to learn more about JWTs, there's this really cool website called jwt.io. And there you can learn more about it. This is also an open technology. So everything I talked about today is just open. So Josh, you can go learn more. You can also play around with it and see how, what I really recommend, there's like this little playground on the homepage. They'll show you a JWT. Try to change some of the data in the payload, and you'll see how that JWT changes and it's corrupted basically. So that's how you know, like, if it's been tampered with. And so you'll be able to visualize how, basically, you'll be able to determine if a JWT has been tampered with at all.
Very cool. And that does lead a bit into the next question of, are there any real world scenarios where it's led to improper use? And I feel like you already answered this with because you said that people can change their private key and be able to mitigate this. But is there any that they've been caught or gone publicly that's caused more?
No, actually, it's been proven to be more secure than like methods we're using today. Even Aruba. So I've been following that use case because I just find it fascinating that I'd be able to like enter a country with a JWT, right? But they're finding like it's more secure. They've had like 0 instances of fraud, and they're able to detect this a whole lot better than like having a human being like review your passport and like look at you and try to make sure like everything is okay. With this JWT, it's all done programmatically, and so it's even more secure.
I can only imagine that this is going to save us so much time for anyone traveling.
Yes. Like
Uh,
the time piece is really the kicker. I don't even feel like I emphasize that enough, because I could issue myself a JWT, right? With basically data that I enter in forms all the time. How many times have you entered a form where it's your name, your address, these basic details about yourself? I can issue myself a JWT and then provide that anytime people need that information, right?
that totally makes sense. And these next two questions might actually go hand in hand, but
Okay.
is it based on Web3?
It's not based on Web3. If you catch what I said, this library is called, it's Web5, which is like tongue in cheek. Basically, it's some of the principles of Web3, which is decentralization, but with technology of Web 2. So it doesn't use blockchain at all. There are some verifiable credentials that can use blockchain, but our Web5 library does not. So we're all about like finding solutions that do not have to rely on blockchain, and we were able to do that here. So the
All right.
Web5 is like Web 2 and Web 3 go together kind of thing.
I was going to say, are there other use cases for Web 5?
Yeah. So the Web5 piece contains 3 different components. One is the decentralized identifiers that I talked about. So you can imagine like identifiers being used like all over the web. If we think about the web now, every application that I go to, I basically have to create a new account. So the decentralized identifier is a way to allow you to have an identity on the web that you can reuse across accounts so that you don't have to keep recreating the accounts over and over again. And that belongs to you, right? Also, with the verifiable credentials, that's the second piece. I told you all about that today. And then the third piece of Web 5 is decentralized web nodes. So these are personal data stores that, like, maybe if I'm using an application with my decentralized identifier, they could also write data or read data to my personal data store, which I also can take across the web with me. And so imagine a case where maybe like I just saw a tweet yesterday that was like, man, I'm so sick of Spotify, but like I've been here for 10 years, so I can't like go anywhere else. Imagine if like all of your playlists and things like that were stored in your own personal data store, then you could easily go to another app and you're all set.
Thank you. All right. Next one, it looks like we have time for maybe one more, maybe a few more. We'll see what we get. Show us the example. How can we use JWT to verify user in our own front end web app? Please show example in React. Do you have some examples created that you can share out after this?
Yeah, if you go to developer.website.com, we have a whole section in the docs for like VCs. So you can see like some example apps created and things like that.
Thank you. And is there any need to use access tokens additionally?
So like I'm assuming this means for like the login piece that JWTs are typically used for. Yeah, you could still use those as well. The credentials piece would be more information about the person. So not necessarily just their login information, but like some sort of qualification that this person may have, right? So for example, I could think of a scenario where I'm like, all right, you use a JWT to log in, but then also you have another JWT that's a verifiable credential that says you have certain like status or something like that, right? Maybe this comes from an airline or something like that.
All right. Can JWT be used for two-factor authentication?
I believe so. I believe it can be used with two-factor authentication.
That'd be really cool.
Yeah.
Does it use public key infrastructure?
Mm-hmm. Yep.
All right. And doesn't that mean the safety is dependent on the user behavior rather than JWT mechanics? Or did they get that wrong? Losing JWT is dangerous, like losing an ID.
So again, the JWT itself is like not enough. You have to have your private key that's associated with your decentralized identifier in order to verify that you are the rightful holder of this verifiable credential.
Are there any questions that you think that normally come up in this that we haven't really asked on here?
No, I think the audience did a great job.
Great. Then I had one other question that came up. So give me, is there a particular node library that you recommend?
For generating JWTs? I have a library per se, but I believe some may be listed on jot.io. For verifiable credentials specifically, of course, I recommend the Web5 library for that one. Again, that's open source.
Okay, perfect. Well, thank you so much. We greatly appreciate it.
Yes, thank you, Jen.